50 interview questions and answers. Topic: Google Firestore. Level: Advanced. Question 1. What are the advanced data modeling strategies in Firestore?
Advanced data modeling in Firestore involves designing collections and documents to optimize queries, scalability, and cost. This includes using subcollections, arrays of references, sharding counters, and splitting large datasets into smaller documents.
Question 2. How does Firestore handle high write throughput and avoid hotspots?
Firestore distributes writes across multiple documents automatically. To avoid hotspots, developers should avoid sequential IDs, shard counters, and distribute updates across multiple documents or collections.
Question 3. What are Firestore collection group queries and when are they useful?
Collection group queries allow querying across all collections with the same name, regardless of parent document. They are useful when you have similar subcollections in multiple documents and need to aggregate or search across them.
Question 4. How do Firestore transactions work under high concurrency?
Firestore transactions provide atomicity and consistency. Under high concurrency, transactions may fail due to conflicts and should be retried with exponential backoff. Each transaction can read and write multiple documents while maintaining consistency.
Question 5. What are Firestore best practices for indexing complex queries?
Complex queries may require composite indexes. Best practices include creating indexes only for queries you need, monitoring index usage, avoiding redundant indexes, and using array contains any or in queries with indexes efficiently.
Question 6. How do Firestore multi-region replication and availability work?
Firestore automatically replicates data across multiple regions in native mode. This ensures high availability, durability, and disaster recovery. Reads are served from the closest region and writes are synchronized across regions.
Question 7. How does Firestore pricing impact advanced query design?
Firestore charges for document reads, writes, deletes, storage, and bandwidth. Advanced query design should minimize unnecessary reads, use indexes efficiently, and avoid fetching large collections to reduce cost.
Question 8. How do you implement role-based access control in Firestore for enterprise apps?
Role-based access control can be implemented using Firebase authentication custom claims combined with Firestore security rules. Each user can have roles that define permissions for reading or writing specific collections or documents.
Question 9. What are sharded counters in Firestore and why are they needed?
Shard counters distribute increments across multiple documents to avoid contention on a single document. This is needed for high-frequency writes, like counting likes or views, without creating hotspots.
Question 10. How do you manage Firestore subcollection performance?
Subcollections are lightweight, but queries should avoid deep nesting. Use shallow queries, indexes, and collection group queries when aggregating data across subcollections for better performance.
Question 11. What are Firestore array contains and array contains any queries?
Array contains checks if a document field array contains a single value. Array contains any checks if the array contains any of multiple specified values. These queries require indexes and are useful for many-to-many relationships.
Question 12. How do Firestore offline persistence mechanisms work across platforms?
Firestore caches data locally on Android, iOS, and web. Offline writes are queued and synchronized when the client reconnects. Listeners receive updates once the device is online.
Question 13. What are Firestore listener types and use cases?
Listeners can be on single documents or entire collections. They provide real-time updates to clients. Use document listeners for specific data and collection listeners for dynamic lists or dashboards.
Question 14. How do Firestore cloud functions integrate with triggers?
Cloud functions can trigger on document create, update, delete, or write. This allows server-side logic like notifications, analytics, or data transformation in response to Firestore events.
Question 15. How do you optimize Firestore query performance for large datasets?
Use indexes, limit the number of results, use pagination, avoid fetching large collections, and denormalize data when necessary. Collection group queries and selective fields reduce bandwidth and improve performance.
Question 16. How does Firestore handle eventual consistency versus strong consistency?
Firestore provides strong consistency for single documents and indexed queries. This ensures that reads always reflect the latest committed writes, even across multiple clients or regions.
Question 17. What is the difference between Firestore native mode and datastore mode for advanced use cases?
Native mode supports real-time updates, offline persistence, and mobile, web SDKs. Datastore mode is better for legacy apps needing datastore compatibility but lacks real-time capabilities.
Question 18. How do you handle complex one-to-many and many-to-many relationships in Firestore?
Use subcollections for one-to-many relationships, arrays or reference arrays for many-to-many, and consider join collections or denormalized structures to simplify queries.
Question 19. How do Firestore composite indexes support complex queries?
Composite indexes allow sorting and filtering on multiple fields simultaneously. They are required for queries using multiple where clauses with order by.
Question 20. How do you handle transactional conflicts in Firestore?
Conflicts occur when multiple clients try to modify the same documents. Use retries with exponential backoff and minimize document contention to handle conflicts efficiently.
Question 21. How do you perform bulk data operations in Firestore?
Use batched writes or parallelized scripts with the SDK. Batched writes are atomic, while parallelized operations increase throughput but require error handling.
Question 22. What are the Firestore limitations for document size and field count?
Documents can be up to 1 megabyte and have a maximum of 20,000 fields. Nested data and large arrays should be split into multiple documents.
Question 23. How do Firestore security rules handle advanced conditional access?
Rules can use request, auth, resource, data, and custom claims to define fine-grained access. You can check multiple conditions, nested fields, and collection membership.
Question 24. How do you monitor Firestore usage and performance metrics?
Use Firebase console metrics, cloud monitoring, and performance monitoring tools to track reads, writes, storage, and latency.
Question 25. How do you migrate large datasets to Firestore efficiently?
Use Firestore import, export, batch writes, and structured collections to avoid write contention and maintain indexes during migration.
Question 26. What are Firestore best practices for sharded counters in analytics applications?
Distribute increments across multiple documents, use collection group queries to aggregate counts, and monitor write distribution to avoid hotspots.
Question 27. How do you handle multi-region replication consistency in Firestore?
Firestore ensures strong consistency per document. Developers should avoid reading unindexed large collections immediately after writes in high-latency regions.
Question 28. How do you design Firestore for low-latency mobile apps?
Use shallow data models, enable offline persistence, index frequently queried fields, and minimize network requests.
Question 29. How do Firestore batched writes differ from transactions?
Batched writes group multiple writes but are not atomic if failures occur. Transactions allow reads and writes atomically and retry on conflicts.
Question 30. How do you manage Firestore document versioning?
Use timestamp fields or version counters in documents to track changes and prevent overwrite issues.
Question 31. How do you implement caching strategies with Firestore?
Use client-side caching with offline persistence, cloud functions to cache aggregated results, or integrate with CDN for static queries.
Question 32. How do you handle hierarchical data in Firestore?
Use subcollections, references, and collection group queries to represent parent-child relationships efficiently.
Question 33. How do you enforce data validation in Firestore?
Use security rules and server-side cloud functions to validate data before writes, ensuring type checks and business rules are applied.
Question 34. How do Firestore listeners scale with large datasets?
Listeners can be scoped to specific documents or limited queries. For large datasets, pagination and collection group queries reduce data load and cost.
Question 35. How do you integrate Firestore with BigQuery for analytics?
Export Firestore data to GCS and then load it into BigQuery. Use scheduled exports or cloud functions for near real-time analytics.
Question 36. How do you design Firestore for multi-tenant applications?
Use separate collections per tenant, security rules scoped by tenant ID and structured naming to isolate data and prevent unauthorized access.
Question 37. What are Firestore field transforms and how are they used?
Field transforms like server timestamp, array union, array remove, increment allow atomic updates to fields without overwriting other data.
Question 38. How do you implement analytics counters efficiently in Firestore?
Use shard counters, batch writes, and avoid writing frequently to a single document to reduce contention.
Question 39. How do Firestore query cursors work for advanced pagination?
Use start at, start after, end at, end before with document snapshots or field values to paginate efficiently across large datasets.
Question 40. How do Firestore cloud functions handle retries and failures?
Cloud functions automatically retry on failures depending on trigger type. Developers can implement exponential backoff and idempotent logic to handle retries safely.
Question 41. How do you implement full text search with Firestore?
Firestore does not natively support full text search. Use integrations with Algolia, Elasticsearch, or Firebase extensions to index text fields.
Question 42. How do you handle schema migrations in Firestore?
Firestore is schemaless, but migrations can be handled by batch updates, cloud functions, or writing scripts to transform documents to the new structure.
Question 43. How do Firestore write limits impact high-scale apps?
Firestore limits writes per document to prevent hotspots. High-scale apps should shard data, distribute writes, and use multiple collections for heavy write workloads.
Question 44. How do you implement access logging for Firestore?
Use cloud audit logs to track reads, writes, and deletes. This allows monitoring and compliance reporting for sensitive applications.
Question 45. How do Firestore composite indexes affect query cost?
Composite indexes may slightly increase storage cost, but they enable complex queries to run efficiently, reducing read and compute cost per query.
Question 46. How do Firestore security rules simulate conditional access for testing?
Use Firebase Emulator Suite to test security rules locally, simulating authenticated and unauthenticated users with custom claims.
Question 47. What are Firestore best practices for hybrid apps with offline-first design?
Enable offline persistence, design shallow document hierarchies, batch writes, and sync selectively to reduce latency and data usage.
That's the end of Google Firestore. Explore more interview questions and answers on our channel, Interview Guru. If you found this helpful, please like, share, and subscribe for more learning content.